That's it. Okay. So we have Richard, Robert, Jim, Buddy, Lori, Jack / Dave, the other Robert.
I think I got my name changed in time.
It's all good. So how is everyone doing?
This is a 46-inch plasma TV, by the way.
Plasma TV. Can you define plasma? I've never heard of it before. Everyone knows everyone else in many cases, so we're very familiar. But just so you know, Richard is the gentleman who runs our Discord server for all the people who like to chat constantly with no limits with regards to Electric Universe. And the Electric View has a channel there. And we have about 50 people or so who pop onto rooms and chat with each other and post videos and so forth. I can't express my gratitude to Richard so much for this because it would be impossible to do by yourself. And because he's there and people like Ramon and others and myself just jump on there to say hi and so that people get to just have a random chat with us. So we get to do that. And of course, everyone here is more than welcome to be invited to that as well. I'm sure Richard could drop a link in there for you. Of course, Robert Hawthorne is Robert Hawthorne's father, so there's senior and junior here. The one with the face is the junior. The one with the RH is the senior. And he is an expert on, I would say he knows more about theology than I'll probably ever learn. So I'm very impressed with his breadth of knowledge. He's a great storyteller. Jim, of course, an astrophysicist, knows his expertise on what I've noticed in regards to the local area of the sun and our part of the galactic arm, things that we don't even think about. This is what he thinks about, and it is very deep thoughts. Of course, Buddy, Lori, I don't know you, so Buddy, tell me about Lori.
I'm Lori.
Real quick. I met Lori at Bridges Mathematical Art and Science exhibit thing in Ontario. Or wait, where was it?
Yeah, it was in Waterloo, Ontario.
Yep. And this, ladies and gentlemen, is Fractal Woman. And she literally blew my mind.
Welcome to the March 31st edition of the Electric View. I'm Neil Thompson. Today we have Richard, Robert, Jim, Buddy, Dave, and Matt with our special guest Lori Gardi, who is with us as we explore her work and the fractal nature of the universe. Please take a moment to like and subscribe. Go ahead. I'm sorry, Lori. Please. Buddy.
If you look up Fractal Woman, you're going to find me.
Oh, okay.
If you look up Fractal, you're going to find everything. It'll be about me, probably. So that's an easy gig. Do you want Lori to tell you about Lori?
You know what?
I
was only introducing you. I was only mentioning Buddy to introduce you, but go ahead. Either one. Talk over to each other.
That was the brief introduction.
Okay. Yeah, no, like Buddy and I hit it off like within minutes. I met him like as I was driving into the parking lot to that conference, and I saw him. He was wearing a costume, and I'm like, oh, I should have worn a costume. And actually, technically, I did because I had a giant fractal shirt that I made to wear around the conference. So, yeah, so that was really great.
What conference was this?
There's too much. It was the Bridges, the Art Meets Science. I
didn't even know that was such a thing, and certainly did not know it was in Waterloo.
It's held in a different city every year.
Ah.
So that year it was in Waterloo. The year before it was in Seoul, I think, and next year
different country.
In Stockholm or something this year. I don't know where they're having it this year, but because I live in London, Ontario, which is only an hour away from Waterloo, so it was easy for me to go to that conference.
It's actually kind of funny because there's a lot of Canadians here now. I'm from Moncton. Chris is from Fredericton. Richard, okay. I believe, is from Toronto. Are you, Richard? I guess he's probably still hooking something up, but still working with his television.
Yeah, a lot of Canadians.
Yeah. We're like a plague. We just sort of spread out.
Yes, Yes, I am
Taking
in
over the
Toronto.
world.
Yes, we're going to politely take over the world. Please be seated.
Yeah.
One
I
smart
am in.
person at a time.
Yeah, I am in Toronto, and I am still building this TV stand. So carry on.
I'm just enjoying this conversation already. It's just nice to meet new people, Lori. And it's nice that you went to this conference in Waterloo. I have not even heard of this thing.
Yeah.
There's some good stuff in Toronto.
I have a funny story about the conference that happened to me. Okay. It was an art meets science conference. Okay. And so I'm an artist, but I'm also a scientist. I'm actually a computer scientist. And, I have my own like black hole theory, but it's based on fractal geometry. I don't know if you ran into that, but so I wrote up a beautiful paper, submitted it to the conference, and they rejected it. But they rejected it in the most god-awful way you could imagine. They trashed me.
Oh.
They trashed me. Like, so badly. It was like, how dare you not, go against relativity, and, like, if you read the letter, you would be shocked. It was so bad, it made me cry.
Oh, that's not cool.
You know what I mean?
No. We've had
That's not cool.
The stories that you're telling here, like this, I bet you every one of us have had to run into that person who goes, no, you must believe in the sacred story.
Yeah. Because like, my black hole theory is a beautiful theory, like literally because it's based on the Mandelbrot set, which is the most beautiful fractal, in my opinion. Okay. So I thought, more art meets science. Surely they'll see the beauty in what I'm saying. No, whoever reviewed they actually had peer review on the paper.
Right.
It was just a conference. Like, it's not that it's just a conference, but you know what I mean? Like,
oh no,
it's not like I was, and it should have been fun. I thought it was going to be fun, but they spoiled my fun. But
I'm glad you went anyway because you met Buddy. So
I did, and I went and I did the art show. My art got accepted. So, I did my art show, which was great, and that's where I met Buddy, and, we had a great conference. So, but that hurt my feelings a little, but peer review, right? I rewrote the paper and made an even better paper. And then I presented it at the John Chappell Natural Philosophy Society conference in Vancouver.
You'll get more love there for sure.
I did. Yeah, it was way better. I don't know if you know about that group. They're actually looking
I know. The word natural philosophy is all I need to hear.
Of course. Yeah.
It's very close.
Natural Philosophy Society, yeah.
It's closely linked to people. Basically, in fact, it could be argued that the electric universe is somewhat the third, I guess you could say third leg of the electric universe. If I was to put the legs in a strong strength order, there'd be plasma cosmology, Velikovsky, catastrophism type stuff, and all that entails. Natural philosophy is a big aspect to that because there is a known situation that me and Jim have argued on that several times. Just the point that you can have a society, and when you're talking about they fractured it, the sciences, and they no longer have people who are generalists, people who were who would connect disparate sides of a coin.
Yeah, and that's exactly what I'm doing. So my goal is to reconnect all those things. So there has to be an underlying philosophy, and there has to be I'm a computer scientist, right? And I want to rewrite the program. So that's what I'm trying to do. I want to rewrite the program. The program is really bad. Relativity and quantum mechanics, the language is terrible. I hate it. And trying to learn it.
Okay, you're in the right spot. You're in the right spot because, to be frank, we've left it a long time ago.
It's terrible.
No one here, I don't think anyone here, I'm pretty sure anyone in this room would go, relativity. Yeah, that's on solid footing. I totally believe that. I don't think anyone here would say that. So
there are, basically what I do is I collect puzzle pieces, right? And so even relativity has something I can take from it like everything that I've studied, I've been able to take, oh, this is the good piece, and this is, it's the language is the problem. The language is the problem. That's where they're making some really big mistakes. And so I want to fix that, and that's what I'm doing. And I think I'm really actually doing it. Really, I'm very close to having a final draft on, a new language that unifies everything. So instead of unifying relativity and quantum mechanics, I'm unifying principles. And it's too hard to explain right now. I call it the principle of incommensurability, a term that I got from Ken Wheeler. You probably know who Ken Wheeler is.
Yep.
Some of you might know who Ken Wheeler is. So, he called it...
Everyone here knows who he is.
Yeah, so good. I'm glad you appreciate who he is, or I hope you appreciate who he is.
Oh, I will argue with him a lot, but still. I argue with a lot of people, so it's fine.
With him, it's the language barrier again. It's a language. So I'm trying to take his stuff and rewrite it in a way that people can understand. And that's what I have a video series on that. It's called Understanding Ken Wheeler's Missing Secrets of Magnetism. So, yeah, I'm trying to pull all these things together. Everyone's got something good to say. Puzzle.
I want to come back to this then because two things. Number one, this is fascinating. And because when we're talking about the fact that I miss this really. And thank you so much, Buddy, because I know that Buddy has a Russellian, Walter Russell. He went to a conference, and that led to a wonderful group of people who, like yourself, have recognize there has to be sort of a harmony between philosophy and science in the way that in an artistic sense, so that we can make sense of it. In addition, the philosophy of science, of course, being physics as it is, broken down into numbers and so forth. But then they lose, as you said, through language or through misconception, lose what the heck they're talking about. That's also very fascinating. But also, I'd like to apologize for what's about to happen, because you're about to start talking about the electric universe, and you're going to go, whoa, what? And it'll be a lot of fun. So enjoy the next 12 years, because that's how long it took me. This is fantastic. So we're going to move right on down the list there. Obviously, everyone knows Buddy. Jack-David Klinger. Who sends me so many pictures. I'm going through them and I have to go, okay, let's get okay, recognize that. Okay, no, I'm going to have to blow this up on my full screen and look at it. What the heck is he pointing out here? That's how my conversations with him go. So how are you doing there, Jack?
I'm good. I'm nuts.
I think Cameron has just joined, so I just heard him pop in there. Anyway, go ahead, Jack, Dave. Jack, Dave.
I'm here. Can you hear me?
Yes, I can hear you. Go ahead.
Probably nice to be able to talk to people.
Yes, that's why I made we wanted the Discord group to still be up and to do this as well, because talking and getting people out there who have different points of view on the electric universe is, it's a community, and it doesn't have nearly enough voices. There's no Cosmos TV show besides the Thunderbolts Project, and there's no Bill Nye the Science Guy thing. There's no conferences televised all the time. There's no arguments. There's just people on forums yelling, and it's not exactly how the most conducive work is done, I guess. Go ahead. I didn't mean to interrupt totally and ran you right out of the room.
I'm just happy to be a fly on the wall. I'm in a conversation in a group with a physicist. I think I'm doing pretty well.
Well, yeah, I got an
astrophysicist.
Yeah.
Astrophysicist, even better.
We have a computer programmer, an electrical engineer. We have, there's a whole group here. We're all crazy. What's your expertise there, Matt? Psychology? Yeah, the psychologist. Oh, the fourth leg. Thank you very much. And the fourth leg of the electric universe, in my opinion, is probably something along the lines of Julian James's evidence with regards to the psychology of man over time. The bicameral mind, yes. It's a well-loved thing by the Electric Universe people because it shows there's evidence in his book that shows that something happened about 2,700 years ago that made us into us. And he said before that, we were very weird, and we spoke very weird, and we did very weird things. And he didn't know why exactly. He had an idea, but he didn't know. And so, of course, combine that with a little Velikovsky evidence from a different source entirely, and, well, you end up with a connection, if you know, a merger. And that's that natural philosophy that we were talking about earlier with Laurie there. When you combine that, brings things together.
What did he say the change was?
Well, he thought that the change was due. Something happened. He thought, like, his big comparison was between Homer's The Iliad and the Odyssey, and he referenced in the Iliad, which this is basically a thesis. It's about 1,500 pages long, but his concept was that they didn't have an idea of what the concept of I was. That there was no inner monologue in your head. That they were conscious but not self-conscious. That they were not separated from themselves, and they would not say things like, back in Homer's The Iliad, they would say things like, I hold that within my eyes. Hera come spoke to me, I did her bidding. You know, that type of stuff. In the Odyssey, Odysseus was a normal human being going, how the hell am I going to get through this problem? I see that guy over there. We need to go around him. We're going to kill this Cyclops. Everyone ready? You know, and it was a completely different mindset. And that he realized that around something happened just at the birth of, Siddhartha, Buddhism, Confucianism, Taoism, all of the birth of the fall of the Etruscans and the birth of the Roman Empire, all that kind of thing, something happened that we all became us. And before that, we were very literal. That's what makes myths confusing, because we automatically throw upon a myth the idea that it is mythic, that it is a metaphor, that it is a story to tell, where they were saying, no, this thing just came down, burned that mountain up, and killed everyone in that field. Like, that's not what happened. That's what happened. Like, it's not a metaphor. No metaphor here. So that idea was the interesting evidence that sort of supports Velikovsky. Even Velikovsky didn't even know about it, and Julian James didn't know about Velikovsky. They were completely in different fields, but they merge at exactly the same point and say the end of the last events in the sky was about 700 BC. After that, the skies were more like what they are today.
It's interesting.
Let's get back to then I was having a wonderful conversation regarding the ideas of black holes. And Laurie, you were now in the Electric Universe. There's obviously, for those watching at home or whatever, there is the idea that in most cases, we're under the impression that they are plasmoids. The effects that they have, the pulling towards the center of is the Lorentz force, the force that allows you to shrink coins.
In terms of the plasma universe, the reason I really like it is because it supports the fractal paradigm, right? Because plasma and plasmoids are scalable structures. You can have cosmological ones like galaxies, and you can have, small ones that you can experiment with at your scale. So they're scalable, which puts them in the realm of the fractal paradigm. And so that's the main reason that I started leaning towards the electric universe. It makes sense, right? You need a scalable, the laws of physics as they currently stand in the standard model in mainstream are not scalable, and that's the mistake they're making. They cannot scale the laws of physics. They do, actually, because the gravitational force equation and the Coulomb force equation are exactly the same, right?
They are,
so, yeah. Right? Mm-hmm. So they don't recognize that they've actually scaled the laws of physics by doing that, and that the laws are similar at both scales. Not the same, but in the fractal paradigm itself, similarity, not self-same, right? So It's similar phenomenon going on at different scales. So that's what those two equations mean to me. They're scaling the laws of physics. They just don't realize it, right?
Oh, yes.
So they're already unified, technically, in my mind, right?
I think
so
that they...
if you plug in Planck mass in the gravity equation and Planck charge in the Coulomb equation, you get the same answer. The force is unified.
What was that?
Which
The
is
Planck...
cool. If you plug in, so in the, what is it, F equals GMM over R squared, the gravity
Gravity,
equation,
yeah, the gravity equation, yeah. Mm-hmm.
The gravity force equation, right?
Mm-hmm.
If you plug in Planck mass to that, okay, and then you take the Coulomb equation, F equals KQQ over R squared,
mm-hmm.
you plug in Planck charge in there, you get the same answer. You get the same answer. You get the same force. The forces are unified when you do that.
But we know that gravity is a significantly weaker force. On the whole, I mean, the G constant is significantly smaller than the K constant.
But that's only because you're forgetting to scale the laws of physics. If you shrunk yourself down to the scale, the quantum scale, if you shrunk yourself down, the force would feel the same. So there's scale relativity. So relativity is missing. They have, all the other relativity stuff, but they're forgetting scale relativity.
We actually have a big debate whether or not relativity is even real. Large debate on that for us.
I know. I don't like when people say this is real and that is real, because there is a phenomenon that they're trying to describe in relativity, and that's real. Okay? Maybe the math that they have isn't right, or something else is wrong in their interpretation, which is where I come in.
When you throw dark matter in the equation, they're probably wrong, but but yes, go on.
Well, dark matter. Okay, there is a phenomenon, which is the reason why they realized that there was something. There's not nothing. It's not dark matter. It's not matter at all. But there's something, and they're trying to describe it, and they call it dark matter. And I have a dark matter in my model too, right? So you can't just say there's no dark matter without replacing the phenomenon, which is the flat rotation curves of galaxies, right? That's one reason we think there's dark matter, and the way that galaxies clump also gives us, there's at a different scale. So that is why we think there's dark matter. That's why they think there's dark matter. That's why they invented it. But
I love that. I like that you said that, actually. They invented it.
Fractal geometry solves it. It solves it. Fractal geometry solves it. At least if you look at my black hole model, which is the Mandelbrot set as a quasi-black hole. Look it up. The Mandelbrot set as a quasi-black hole. Perfect. And there you go. I have a video on it. You can click on the paper, because then you can scroll through it. Right? So go back. The second one in the list, click on that. That should be my ResearchGate one.
Oh, cool.
Yeah. And this is what I present. I submitted to that Bridges conference where they gave me like a terrible review.
Okay.
And then I rewrote it and made it better. So this is the better version. It's much, much better. I mean, they forced me to, because I had to address their issues. I didn't just ignore them, even though they were harsh. I still took it seriously and said, okay, how can I explain to them, what I'm trying to say without insulting them and saying, so basically I avoid relativity by saying, what if Einstein never existed? What if relativity was never invented? Could we still have a concept of a black hole? And I say yes, because the Mandelbrot set taught me that black holes, that this is the equation for black hole, in my humble opinion, the black holes that nature makes.
We should actually give credit to Einstein as well, because even Einstein, Eddington, as much as I will totally trash Eddington in a little bit, and his students, it was his students were the ones who, specifically one student, Suleiman Chandrasekhar, he was the individual who ended up inventing black holes. And what he did was he basically divided by zero. And that argument, he said, no, you can't do that. The same way that Tesla said, you can't
do it twice.
Yeah. Well, see, Eddington had the basically he wanted to become famous. He grabbed a hold of Einstein and said, I'm going to prove Einstein right. And then that was May 1st, 1919, when he did that observation of the sun, saw the little dot move, and then claimed gravity bent light. There's no evidence that that's true. So, no. But we did see a movement, so that should be noted. There's no reason to deny the data. We just deny the theory. And that is...
Exactly. You have a different explanation.
Well, that happens to fit the facts, and also does not self-falsify. Right. In my argument with regards to the reason I brought up dark matter, and I'm happy that you're here because it forces me to explain these little off-the-cuff jokes. We often get sucked into you can get basically stuck in your own echo chamber with regards to things like the electric universe. You'll hear people making fun of Neil deGrasse Tyson. How stupid is he? How stupid is he? How stupid is this guy? And so forth.
Yeah. I hope you try not to do that.
I do very much try not to do that because Newton was not an idiot. He did nothing wrong, and he made no mistakes. It was his followers later. I think the only thing that was ever problematic was the word universal get struck under the top of it, and that's good. Right. But but that's what happens when you're dealing with. I'm sorry, just laughing at your video there. I know. But it's good. It's good. But when it comes in and it does that, and you see the what happens to people, it's the same thing when like. In the falsification aspect of, for me, the Big Bang paradigm is dark matter. In most cases, not most cases, I'm sorry. All cases, besides this that I know of, maybe one other, the theory has to be so sacrosanct as to never be questioned. The issue becomes when suddenly you are plotting the galaxy curve, and you end up having the curve not adhere to a spinning vortex as it should if it was surrounded by a massive black hole, then there must be additional mass somewhere else, somehow holding this together. That is the explanation. And the reason for it is because when you get right down to it, the equation says blah, this is how much mass there must be. The discrepancy is between these two numbers, what we see and what there should be. Therefore, they say additional mass. Now, the problem is that that's not science, not remotely. That's not how any of this works. Okay, when you come up with something like that, that is called being wrong. And when you're wrong, you are supposed to start again because you're wrong.
Exactly.
And they didn't take no for an answer. They literally just walked right on and kept on going.
Their assumption was wrong. The assumption was that all the particles in the galaxy are orbiting the black hole, like the planets orbit the sun. That was their big mistake because they are not orbiting any more than, let's say you take a hunk of metal and you spin it, and the particles on that hunk of metal are not orbiting the center of the hunk of metal, you know what I mean? The galaxy is one object.
Yes,
it's not a bunch of objects orbiting a black hole. It is one
Correct.
Object.
That concept is
right.
It's amazing that you've reached this and not even gone through the same path that we've gotten. I'm very impressed by this.
Thank you. I think it's obvious, and that's why we're all getting it. We had to sift through the crap, right? We said to know what to throw away. At least that's what I had to do because I tried to do it their way and I couldn't do it. And I realized, oh, there's a bug in the program. There's a bug in the program. And I have videos on that too. Basically,
well, you're doing the same thing we're doing.
There's a bug.
Your story is not unlike Jim's. Jim, you were saying the same thing when you were you encountered this same situation. You tried to work very hard within the confines of what they were providing. Now, because of that diligence that you put forth in your work, if I'm not mistaken, this allowed you, like, you've showed me stuff that I don't see because of that reason, because you're still very much attached to the data itself, and you know basically the intricacies of what they're talking about, but still they have a lack of concept. They still refer to things as clouds and stuff like that. Am I wrong there, Jim? Or
Yeah, you're right.
yeah, I think you were just involved in that. I think you tried to work in their field, but like you said, it's very hard. It's now luckily I've as much as I very much enjoyed the science when growing up and was but the popularization of a certain concept or a certain idea was not what science was. Like, something weird happened in the 60s when Star Trek happened, where everyone sort of it's suddenly things like quantum space, subspace, hyperspace, alternate dimensions, and all that became something that was real. But there's no evidence anywhere at all that space bends, or that we can bend or break through to another dimension. There's some scant evidence based on some, we'll call it spooky quantum stuff, but we're not even sure what we're looking at there. So
look at the screen. It says space-time curvature.
I know. Oh, that drives me nuts. I used to
God.
do this thing at parties, you know, with the garbage bag, you know, and show, like, that's how much of a nerd I was. That's what I was doing to get laid. Oh my God, I was terrible. But still,
How'd that
work out for me? Yeah, not good.
Fractal geometry doesn't contradict space-time curvature. In fact, it explains it. Fractal geometry explains why I don't say space-time, but why space is curved. It's fractal curvature. It's not it's not trampoline curvature. It's a different kind of curvature that, unless you understand fractal geometry, you don't understand it. That's why I don't have to contradict space-time curvature. I'm just redefining it. So you see the curve on the Mandelbrot set, that outer edge? Mm-hmm. That fuzzy part, that's a curve. It is literally a super, super, super freakishly complex curve, right? And I believe that that's what space-time is. Space-time curvature. Einstein had an insight into that, and it is a curvature, but they didn't understand fractal geometry. They didn't understand scale relativity, and so they couldn't understand how, space-time can curve and create gravity. But my fractal black hole model kind of explains it, and I talk about that in my paper and in this video. So this fractal geometry can explain things, not just describe them. Relativity is just a description; it's not an explanation. It's an output, not an input, right? So fractal geometry is closer to the truth, but it doesn't have to deny space-time curvature. It doesn't see the black part. That's dark matter in my model. And the outer gradient, that's dark energy. And the bright curve on the outside, that's visible matter. Visible matter only makes up, that's why visible matter only makes up 4% of the universe. Look at that curve. That only makes up 4% of that picture. That's where the curvature is.
Can I make a comment?
Sure.
As I understand it, Birkeland currents go from absolutely massive size all the way down to the micro scale. So that is basically the Mandelbrot set and fractalization in
one can not knife
as a basis of the universe itself.
Plasma naturally seems to do this filamentary, and that does seem to go down and down and down and down and down.
It's a minimal. Well, I think what's happening is they're minimal energy configurations and you have surface tension. You have surface tension on all scales. So this minimal energy configuration builds bodies and creatures naturally when you add rotating magnetic fields.
You have volumetric flow and surface tension at all scales. That's the ether. The ether is everything, right? There's only one ether, and everything is like an emergent property of the ether. And the ether itself has surface tension, volumetric flow, that's the magnetic field, and surface tension, that's the dielectric field, but they work together.
I could feel some Walter Russell, Ken Wheeler stuff going on right there.
Yeah. That's Ken Wheeler language for sure.
Yes.
Counter space. So the Mandelbrot set is an embodiment of the principle of incommensurability, which is space and counter space. It's not about the space, and it's not about the counter space. It's the boundary between things. That's where all the cool stuff happens. It doesn't happen. It happens at the boundary, at the interface between space and counter space. That's why you get, the fractal patterns. That's why there's fractal at the edge of the, right?
I'm actually not a big fan of the idea, a lot of the ideas there with regards to counter space. However, much of what you're saying is very much applicable.
It's just a word.
No.
Well, just like frequency and vibration is responsible for creating all matter in the universe.
But I could do math with frequency and vibration, though. You see,
here's what I'm talking about on this page is I say 3 domains. There's 3 domains. I call them domains. The domain of counter space, the domain of space, or the domain of light and the domain of dark, and the separator is the event horizon. Okay, that's phenomenon. That's visible matter. That's anything that you can observe is at the interface between 2 domains. You can call them what you want. Black and white, counter space and space, dielectric magnetic, there's all kind, black hole, photon sphere, there's lots of names for it because it's not, counter space isn't a place or a space, it's a principle in my mind. That's how I'm teaching it. That Ken doesn't teach it that way. But it's a domain. It's not a place. It's not a space. Counter space is just a domain. It's a mathematical domain. So it's a conceptual domain. So it's called, if you saw my videos, you'd maybe have a better idea what I'm talking about. But that's how I'm rewriting the program. I'm rewriting the program, and that's my base class. The principle of incommensurability is my base. I'm rewriting. I'm going from procedural programming to object-oriented programming. Fractals are object-oriented programming to me. So I'm just switching from, the old-fashioned procedural spaghetti code crappy program that is relativity and quantum mechanics, and I'm rewriting the program. And with the Mandelbrot set is my muse. My muse.
So out of curiosity, do you have an idea of where the fine structure constant is in your model?
I actually do. I think I know exactly what the fine structure, I think it's a calibration error. I'm seeing it because I had to recalibrate everything when I rewrote my program, right? And so I discovered that the fine structure constant is a calibration. I think it's a calibration error. There's another guy, Jeff Yee. He's got Particles of the Universe, his video series. He thinks it's like a gear ratio, and it might be like that too. It's like the strong force is 137 times more strong than the electromagnetic force. And so it could also be like a gear ratio, but it is the ratio between elementary charge, which is charge of the particle, and Planck charge. So elementary charge squared divided by Planck charge squared is equal to the fine structure constant. So it is the ratio between what we perceive as elementary charge and what nature perceives as elementary charge, right? That's like both sides of the event horizon. So the fine structure constant, it's either a calibration tweak or it is a gear ratio. And actually, I'm starting to lean towards the gear ratio idea. It's how do you get from one scale to another scale in the fractal paradigm, right? And that's
very interesting. Like I said, there's a connection As much as I do disagree with some of the ideas of relativity, we can't deny the fractal nature of plasma and the way that there is, in particular, an activity that occurs at the boundary layers between solid and plasma. In that area, we have neutral matter, or in some cases, a very highly charged double layer. So there's no doubt in my mind that there is that nature is why we see the fractal nature of space, and of course the golden ratio and so forth. In the same case, when the same structure and tension between these two, let's say, plates, the ionosphere and the ground, for example, start creating light or life. You're going to have it sort of form in the same fashion using the same principles, which is, of course, why we like it. But
so if you find those principles, what are those principles? If you can find those principles, then you can apply them to almost everything.
Well, and that's not missed on most people. In fact, that's like literally Pythagorean right there, like right down to the cult of Pythagoras, as it were, back in the 2,300 years ago or so. So they went down to Egypt. They organized tours to go down to explore and to go see the Temple of Abydos there, and probably why the Flower of Life is sitting on the side of that thing. But still, good guys, as far as I know.
It was probably carved on later.
Well, that's what I mean.
Hang on, Neil. Lori, can you explain what we're seeing here with this triangles? This is real.
Okay, so the black region of the Mandelbrot set, which I'm calling a black hole, right? The black region is different than the outer colorful region, right? When you take a complex point, so you see the real and the imaginary. So the real number is the one on the top, and the imaginary number is that's a complex number. Right. So when you take a complex point on the complex plane in the black region and you iterate it many times, okay, what's happening is the points, which I'm showing by the lines between the dots, right? You can see how it's zooming into a smaller and smaller scale. Mm-hmm. The one on the right, you can see, if you look at the dot, you can see, if you want to go back a bit and stop it, maybe I can explain it a bit more.
Yeah, he'll go back a bit and stop it. No problem.
Yeah, maybe replay that zoom in video. Actually, just there. Start there. That's a good spot. So as I iterate, the numbers are going to change, and it's going to look like you're zooming in on the right. So if you play the video, you'll see you'll be zooming in. Can you play it?
It is playing.
It's playing, but it's obviously you're explaining probably at this point, either before or after the video.
Well, maybe I am. Maybe you're right.
That's what I think's going on. But still, I understand. Can you back up to where it was moving there? I think either back up or speed up. Just check. Yeah, there it is. Okay, so back up to where it starts.
Well, that's
there. That's good. Yeah. Oh, there. That's good. Perfect.
There. Perfect. Yeah.
Aha. There we go. Okay.
There we go. So look at how the numbers change as it zooms in. So it'll start zooming in there.
Don't worry. It'll do it. Yeah. It'll do it in a second. But still.
Yeah. So basically, when you iterate this, I call it a wave function. Mm-hmm. I like reusing their terminology so that they can understand. This is a wave function, and what's happening is each time you iterate, it gets smaller and smaller. It's zooming in towards a singularity. I call it a singularity, which is why I call this a black hole. All the points in the black region do this. They all collapse. This is collapsing, and then at the end it breaks down because I run out of digits. So you see the digits on the left-hand side there. Mm-hmm. The only reason the animation stopped is I ran out of digits. If I had more digits, I could keep zooming. And theoretically, right? So it's just my computer only has 17 digits, and so if I had more, I could keep zooming, and if I had more, I could, it's a bigger computer, 128, 256, whatever, then I could zoom in more. So the limit to the digits of precision of the computer is the limit. This is where the collapse breaks down. So it's interesting.
Would that be a model of implosion as well?
This is implosion. This is implosion. It is implosion. Absolutely. The points on the outside do the exact opposite.
Richard is going to love you, you see.
And the singularity, or expand to infinity. So the both sides of the event horizon do different things. They're incommensurate. That's part of the principle of incommensurability. The points on the inside do one thing, and the points on the outside do another thing. And the points on the boundary do crazy things. Points on the boundary don't know whether they're inside or outside, and they keep going, out and in, and eventually they either escape or they collapse.
See, this is why
that's frequency and vibration right there.
Exactly.
See, so this right here. Okay. This is it for me when I see stuff like this. Is the moment when I'm looking at the idea that, like, I hear Richard. I know Richard obviously loves Mr. Wheeler, and I know that my friend Buddy went to the Walter Russell.
I don't
conference.
know. I don't know Mr. Wheeler, by the way.
Oh, well, you talk a lot about stuff that he's referring to. Perhaps maybe you just heard stuff that he refers to or videos like that. But still, either way.
Hang on, let me insert an addendum here. There is a conference coming up that I will be at with Ken Wheeler and Eric Dollard coming up. It is in Idaho in July. We already have tables, and we're going to be scheduled to be there. It's at the same time as the Thunderbolts Electric Universe out in London or wherever it is. So
we're going to be able to. We'll have to call from both sides, by the way, buddy, because
You'll have to say hi to him for me, because I wish I was going to that. Yeah.
There's only 80 seats left, but yeah, I guess if you're able, I don't know, but yeah, we're going to try to do as much as I can, and I'm going to have stuff to present to him. So anybody who wants me to deliver something or whatever in any form, feel free to email me.
Can you say live YouTube conference from conference to conference? Maybe.
That would be awesome.
I was thinking in terms of have it set up broadcast like on a lunch break or something like that, so that people from over there could say hi to people over here during the lunch break.
That would be ideal.
The non-talking periods.
Oh, I'll have my laptop. I'll be walking around. I'm positive. In fact, if I can, I'll transfer it right to my telephone. I'll just be like, hey guys, say hi to everyone at home.
But on the phone's going to be the easiest because
I'll watch that.
You can sit down and have a group of people. If it's in a quiet room, and turn one phone on, and several people can talk into the same phone.
Oh my God! If we master it beforehand, I can actually. I have Twitch. Like I said, Twitch. We've already ran a test, and it works fine. So all literally my friend would have to do is literally load up my software, which is currently running. That's recording everything, and then he just hits the button that says "Start Streaming," and the moment he hits that. Boom, it goes to twitch.tv to the electric view, and I would just have to make sure we make it pretty with some more banners and stuff. I haven't touched it in a while, but my friend is working on banners right now, actually. So if we do this correctly, then we can go ahead and have all that laid out ahead of time, and then people can just ask questions from anywhere and type in. Doesn't matter where they are.
Sounds good. But yeah, we got to start doing live. We have to start doing the live broadcasting.
Could you imagine that? People would go, oh yeah, no problem. Hey guys, I have a question. Andy. Run over to Andy. This guy here was asking blah, 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 blah. People start asking questions to the conference people live while we're at the conference. Wouldn't that be so cool? Hey, okay. We have a question for Eric Dollar. Eric. That'd be actually really great.
Make that happen.
That would be just the best. So I noticed that Sean has joined. We saw his face popping around there. So hi, Sean. We just basically are talking about this idea, the fractal nature of the universe and so forth. One of the things I noticed, by the way, Lori, is when you were showing that video about when you said at the boundary there's something, but at one end there's something, and at the other end now. Because of these mathematical constraints, the layout that you had put forth, and what it looked like. And I totally get that. But what impressed upon me was the idea if this was, for example, if you've ever seen the difference between Lichtenberg patterns in positive and negative. Obviously, the desire in the electric universe is to try to, or at least in plasma cosmology, especially in plasma cosmology, actually, is to just basically say the universe behaves as it does in the laboratory with regards to little tiny metal balls immersed in a sea of plasma. That's basically what it looks like. And it forms certain structures naturally due to the right-hand rule. When you were talking, for example, about the plate of the galaxy spinning,
right?
That's the exact same language that Wall Thornhill uses when describing the homopolar motor effect of the galaxy, and that, of course, is generating the spin.
It is basically a homopolar motor. Yep, it is exactly a homopolar motor. Seems to be, anyways. Yep, and that would be something Ken Wheeler would say too.
Well, this is why I don't ever, and
it's a giant
I don't
magnet.
bash Ken, I guess, but some of the esoteric stuff that he says, I'm like, that's unnecessary, or maybe that's not required, or are you just guessing this? But sometimes there's little bits of, wait, no, that makes sense. And of course, he
Ken
does
Wheeler's like
many
a gold
times.
mine.
Well, but often he can make simple mistakes. One of the things, for example, I've watched a wonderful video, and it bothered me greatly because it wasn't, it was what people were attributing to it as opposed to what it was. And he had a wonderful magnet, and he was showing a spinning gyroscope, and he said, "Look, when I bring the spinning gyroscope to the edge, it slows down, but I bring it to where more flux is at the pole, and it doesn't slow down. Why is that? It should slow down." And I'm reminded, of course, that bothered me greatly for a moment until I went, wait, no. The original thing is how many lines of force are crossed by a surface area in a disk form, or whatever shape you wish. And those crossings of the line are what actually generates the lag.
Yep.
Exactly. And the eddy currents within
That's
it, the Lenz's law. So when I put that into, but then I realized he's spinning it on the pole of a magnet, and it's not going away or from the magnet. It's just spinning in a disk. So it's actually inside the magnetic field. It's experiencing the same flux at all points, whereas the one on the edge is moving. Each point on the gyroscope is moving towards and away from the magnet at any given time, therefore generating eddy currents within the metal itself and therefore slowing it down. And that minor misconception, especially when he's trying to show magnetic fields and stuff, those minor things can lead to larger misconceptions. That's all I'm concerned with. Other times, I'm like, no, he's nailed it perfectly. I don't have anything to complain about. So it is that thing that I have and you know what? I shouldn't really complain too much because I bet you I do it too. I bet you I have. I was there.
I've made
so I make conceptually exactly. So exactly. So
when I make a mistake, I make in a video. I make another video and say, "Oh, I made a mistake," and then I fix it. Right?
Well, that's how we learn.
He shouldn't be afraid to admit that he made a mistake.
I
think he's a little afraid.
Yeah, there's a certain amount of there's a certain amount of something within him that might make that challenging. That's why I'm afraid to perhaps maybe talk to him sometimes. I'm like, maybe we should have a conversation. And I'm like, you know how that's going to go. He's like, yeah, I know how that's going to go.
Exactly how that's going to go.
So maybe we should just shake hands and say, hey.
Because I think he has a lot of good things to say.
That's what I mean. I don't want to be bad to the guy. Who wants to bash a guy? Right. Yeah. Exactly. He's trying to bring education, and he may not be 100%, but he's trying. And I don't give a,
for sure. Yep. I appreciate it. I know good from bad. Like I say, everyone has a piece of the puzzle. I don't know if you know the work of Robert Distinti. Actually, Robert Distinti made a video on Ken Wheeler's gyroscope. And he basically said exactly what you just said.
Well,
he's an electrical engineer. And he's really good. He's rewriting the program too. He's doing it his way, and I'm helping, here and there, and bringing people together, like Jeff Yee, who is Particles of the Universe, and Robert Distinti. I got them together, and then we wrote a paper on it. So There's really good stuff going on.
How do you spell his name?
Robert, Distinti. There it is. Distinti, yeah. So, the Natural Philosophy Society, the critical thinker one that you're pointing at, that's the group I was telling you about. He made a video on Robert, right? And it's pretty good.
Oh, well, that's good. Huh. Find out what's going on here.
Yeah.
Oh, we don't need to. No, just skip to the pretty stuff. Or is this not him? Or is this?
Oh, no, that's not him. That's David DeHilster, who's the president of the John Chappell Natural Philosophy Society, and he makes a lot of videos. He's got a lot of videos out there, and he, makes videos on other people. So go to distinti.com, yeah. And then he's got.
Work your magic. There it is. Yeah.
Oh,
wow, that's a long neck.
That's the goddess of nature that he uses as his logo. It's nice, actually.
He's just sticking his neck out there. Just taking a risk. I see it. I know he's saying. Either that, or he's like, no, it's a hangman, but I've just been hanging here for a while. It takes a while. You see, it's getting very tall.
Yeah, he's got a lot of really good stuff.
You're great.
What? I'm just saying.
That's great. Those were good.
I just say whatever's on my mind, man. I'm sorry. But as long as it's fun, it's so good. It's all good. I'm not going to hurt it. No need to hurt people's feelings. So what is this gentleman?
He thinks we can break the light barrier.
I'm pretty sure we could too. As far as you know, you already know it's true. You just told me the formula that shows it's true. I mean, you were just talking about it. Force equals G M over R squared, or K QQ over R squared. There's no time factor in that. That means that if Coulomb charge changes here on this sphere, then it will be felt relative to the change to everything in the universe at the same time. If mass was to suddenly leave, which seems impossible, but in electric model probably isn't, because somehow there seems to be a relationship to charged bodies and mass, or an inverse relationship. It's like some of the charge is somehow making the body appear lighter, and that is creating havoc with what we think about the objects in the solar system. For example, this new Ultima Thule thing that we found, which is obviously just not unlike slag from a welding machine, two little spheres sort of connected, flung off, but because the incomplete pinch, as you saw from those coin shrinkage, the weird mangled coins, well, then you have three other spheres that are orbiting it. And there's no way that this thing has enough mass to do that, but it certainly has enough electrostatic potential to do that. And as you pointed out, the models are the same. So this becomes, what the heck is going on here? Because suddenly what they sense gravitationally towards each other is also not what they sense electrically towards each other. It is if you have a bunch of, for example, remember when you were first saying, no, this is what it looks like in visible light, but in infrared, you can see how much more potent this star is than those stars. Oh my God, it's crazy. And you were told that's an amazing difference. Well, the same friggin' thing would be happening to planets, where they see each other gravitationally, but they also see each other electrically, and they see each other instantly electrically, just as much as Andromeda senses the Milky Way electrically. And gravitationally, they're very far apart, but electrically, they probably have a relationship at that distance. And this kind of, well, he's talking about it right here, literally.
So these are his equations. The first one is Coulomb's law. The last one is F equals ma. The middle ones are for magnetism. And these are new. That's what he developed. So they're very interesting. So he's got force equations to describe magnetism.
That's actually
so,
kind
it's
of
a little
interesting.
complicated, but
No, not really. It's not.
so instead of Maxwell's law, which are field abstractions, they deal with the field. His equations deal with forces. So it's force equations are more useful. You want to know if I do something, what force is going to,
Oh yeah.
be applied to something out, right? Maxwell's equations are not.
We don't run
useful.
cars on a dynamometer for no reason. We want to know the force. We want to know the power.
We want to know.
Well,
Right. Exactly.
Wouldn't it make sense that if there's a certain amount of energy flowing through a body or a mass in space, that is what gives that mass its gravity, and the variability of the amount of energy going through those objects is the mistake that Newton made, and also the mistake that Einstein made.
No, I don't think Newton
believe
actually
it's
made any mistakes
light is
given his
variable as
ability.
well.
Given what Newton could know, he didn't make any issues whatsoever.
Most of the mistakes are an interpretation.
No. I mean, he even was very clear. Newton is 100% exonerated from anything. He said, I frame no hypothesis. I have no idea why this force exists.
Exactly.
I'm not basing it on anything. I'm telling you it exists.
Oh.
There it is.
Exactly.
Deal with it. But the trouble is that later...
That's how we do it.
Exactly. And that's exactly what Maxwell did especially when you get to the force equation, Coulomb, I guess, in this case, when he was like, no, boom, straight. This is it. This is it.
The point that I was trying to make is gravity seems to be not variable at the moment, but change the amount of energy coming through the Earth, that might change. And I think it did in the past, where dinosaurs lived in 1/3, 50% less gravity than we enjoy now.
Oh, you're not going to lose anything from us. I agree. I'm not sure the relationship though, and I'm not sure the consequences, whether or not it was induced by an overall change in the entirety of the solar system, or was it more local because of events that were transpiring? It seems to be a longer term thing, but it also seems to have a recent spike. We note that there was dinosaurs way back beyond yonder, and this is just giving credence to conventional geology at the moment. So way back beyond yonder, 65 million years and before, these things were there. There was a bunch of other stuff that was there, but recently, 10,000 years ago, animals were big. There was 200-pound birds that could not possibly fly today that were flying around. There were giant sloths that were just doing the sloth thing. I don't know what they were doing, but they were huge. And it was counterproductive. So, I mean, there had to be an abundance of food.
Wouldn't that coincide with the time that Saturn came into the solar system?
Yes, it does seem to coincide with that.
And we received, and Saturn also received more energy than it did outside of the solar system. And that made one change, and then we disconnected from that polar configuration at one point, and gave us even more energy at that point as well. And
I don't think it was more. I think it was actually a reverse. We started dropping down. But remember, any change in electric potential will, of course, change magnetic field. It's just a variable. But anyway, the issue that we're dealing with, is
like gravity and the speed of light. I think are variables.
Well, that's very true too. But but when you're dealing with, if this was actually a polar configuration and these planets were actually connected to us, we got to understand that if they were in series, what goes through one goes through all, if you know what I mean. So that does change the exact situation. Thanks, Dave. Sorry, I didn't realize it was. Bye.
Well, we know Sapphire slowed the speed of light down. I'd be curious if they could speed it up somehow by maybe adding more energy into the system. I don't know.
Well, the speed of light, of course, is likely and actually known to be in real life. I'm not making anything funky about this. Known to change when it goes through materials. So it changes upon changing
Glass,
density.
for one.
Yes, of course. That's
No.
why.
The speed of light
Right.
is dependent on the medium that it's going through.
That's what we
Speed
just
of
said.
light depends on the medium it's going through.
Right.
Right? And so in space, the medium is, and I believe there's a medium, and we can call it the ether, or whatever you want to call it, fabric, space-time, it's the medium. There's a medium.
Right.
And it's got properties. It's got the
Yes.
property of permittivity and permeability.
Yes.
Okay? Permittivity, permeability times the speed of light has the units of resistance. So that's the inertial part of the ether.
Mm-hmm.
The permeability times the speed of light has the units of resistance. That's inertia. Inertia and resistance are the same thing. Permittivity times the speed of light has the units of conductance. Okay? So permeability governs the inertial forces that we feel. And you can call it impedance or resistance.
Well, no,
impedance
the opposite
are
of a
basically the same thing.
conductance.
Yeah, so they're inverses of each other. Permittivity and permeability are inverses of each other. One governs the inertial properties, resistance, impedance, if you want to call it that, and the other governs the acceptance of change, the conductance, the how much it permits. That's why it's called permittivity. How much it permits change, and permeability is resistance to change. And you need both. You need both in order to have phenomenon, in order to have anything, right? In order to have propagation of light, in order to have matter, in order to have anything, you need two sides of the event horizon, and that's where my fractal model comes in. You need
the universe is dual in nature, right?
Yeah, horizon. It's dual in nature. So I don't like the word dual because it invokes the word duality, and the universe is just one thing. There's only one universe. There's only one Mandelbrot set. There's only one complex plane. But it's got different modalities. It's all one thing. There's only one ether. But ether has, and this is where I got the language from Ken Wheeler, ether has different modalities. One is dielectric, one is magnetic, right? And gravity is dielectric magnetic, and electricity is electric, magnetic. Like it's either side of the event horizon. So there's two sides to the event horizon.
Well, you might be able to call it polarities as well.
That's what polarity is. That's what polarization is. Polarization creates, is on either side of the event horizon. It's polarized. If you look at the Mandelbrot set, it's polarized. You can see it's an embodiment of polarization. It's not symmetrical. It's left-right symmetrical, but it's not up-down symmetrical. It's polarized, right? So the Mandelbrot set taught me a lot. It's a dipole. And I think we see that in nature. If you look at a seed, most seeds are that kind of shape. They're like the pear shape. They're not like perfectly round. Very rare you're going to find a seed all the seeds are polarized. They're polarized.
Well, all cells are polarized as well in atomic particles,
exactly.
Everything.
Yeah. Actually, look up, type in nucleolus, N-U-C-L-E, nucleolus, which is the nucleus of a cell. Yeah, like that. Anyways, I ran into one that looked like the Mandelbrot set to me. And so the nucleolus, the nucleus of the cell, is not centered on the cell. It's shifted, just like the Mandelbrot set is shifted in the complex plane. It's polarized, just like, I don't know who said that, but, the cell
Richard.
is also polarized. Richard. Yeah, I'm not seeing the picture I'm looking for, but anyways, like, you're right. There's polarization is part of the equation. Without that, there's nothing in the universe. It's impossible. So, anyways, interesting stuff.
Well, I believe magnetic fields are also polarized. On the northern pole, one is one polarity, and the southern pole is another polarity.
Yep. There's an asymmetry there. Yep. And Ken Wheeler did some studies on that, where he exposed seeds to the North Pole, and I did the same experiment at work. Alfalfa seeds, you expose it to the North Pole and to the South Pole, and the South Pole ones grow better than the North Pole ones. They grow, they're healthier, they bulk out better, they taste better. There's definitely a difference between the two poles. It's not symmetrical.
Yeah, I'm trying to get my friend to find something that I couldn't find for a moment there, but I was realizing what I was typing in wrong. But go pick one of them there somewhere, maybe the third one down. That'll do. Doesn't really make any difference. And just skip ahead to keep going ahead. Yeah, right there somewhere. Well, not right there, but still. Yeah, so they were trying to figure out what's the what you're talking about is exactly this equation here. The R is the resistance, and your XC, in this case a capacitor, is the permeability and permittivity equation that you're referring to. However, when it starts going forward, because you have an alternating current going into it at 26 volts, so basically it's not a steady stream of current. So you have to basically figure out what the resistance is of those two objects, and the calculation of that, because one's at 90 degrees to the other. They're not opposites at 180; they're actually at 90.
They're
and that's
orthogonal.
Well, and that is the relationship. That relationship, exactly. The relationship between that right angle is what gives you, depending on frequency, changes the permeability. You get my meaning? So everything changes. So you have the physical the resistance of the material is one thing, but then how easy the frequency passes through that material is another, and that's why certain materials will have certain speeds and so forth and blah 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 blah.
Exactly.
Anyway, that's all I wanted to show. So, because I love I love when I was like figured out what power factor actually meant when I was like doing electronics. I was like, oh my god, the world is, this explains everything, because you started like realizing how radio worked, kind of thing. So, anyway, sorry for interrupting, because the nucleolus, and when you were talking about it, I was like, I want to explain it in a way that makes sense without, and I knew I had a visual that I remember because basically it's not perfect on this one, but those U.S. Air Force guys knew how to make a friggin' video. Like they were like, here's how you calculate it, and it was just like straightforward, basic, nothing fancy. This is how you do it. Here's a graph. You blah blah blah. The frequency you have coming in is going to relate to the power factor that you have going through it, blah blah blah, capacitor, yada yada. And I was like, perfect.